Welcome to this training session on lithium-ion battery manufacturing. In this course, we will walk through the complete journey of how lithium-ion batteries are made, from the very beginning of raw material preparation, all the way to the final assembly and quality testing. Our goal is to help you understand each step of the process, so you can connect your daily work in the factory to the bigger picture of battery production. Let's begin our journey from the front to the end of lithium-ion battery manufacturing. Now we move into step 3 of the lithium-ion battery manufacturing process, cell formation and finishing. Up to this point, we have prepared the electrodes, assembled the cells, and filled them with electrolyte. However, the cell is not yet an active, functioning battery. That happens here, during the formation and finishing stage. The formation process involves the very first charging and discharging cycles of the battery. This step is extremely important because it creates what we call the solid electrolyte interface, or SEI layer, on the surface of the anode. This thin, protective layer stabilizes the battery chemistry, allowing lithium ions to move in and out efficiently. Without a high-quality SEI layer, the battery would degrade quickly and lose performance. During finishing, the cells also undergo processes like aging, degassing, and inspection. These steps help stabilize the battery, remove any internal gases, and ensure safety and quality before the cells move on to the final packaging stage. For you as new engineers and technicians, it's important to remember that this stage is where the battery truly becomes alive. The conditions during formation, such as temperature, current, and voltage, directly impact the final performance, lifespan, and safety of the battery. In other words, formation and finishing are not just routine steps. They are the heart of transforming raw materials into a reliable energy storage device that will power electric vehicles, electronics, and much more. At this stage, the cell is charged and discharged for the very first time after the electrolyte has been filled. This is not done at full speed or high current. Instead, it follows very carefully controlled current and voltage profiles at a low rate. The purpose here is to activate the cell's active materials, and to gradually build a protective interface layer between the electrolyte and the anode. This layer is known as the solid electrolyte interface, or SEI. A well-formed SEI layer is absolutely essential for battery safety, performance, and long-term life, because it allows lithium ions to pass through while preventing unwanted chemical reactions. During formation, the charge and discharge rates are gradually increased in steps, allowing the SEI to form uniformly and stabilize. This process is also where the cell is tested under strict conditions, from the very first charge cycle all the way to final surface inspections, making it the last stage of cell manufacturing before the batteries move to finishing and packaging. The video you see here demonstrates the actual formation process in action, showing how cells are carefully cycled and monitored during this stage. Aging, degassing, and resealing. After the cell formation process, the batteries enter the aging stage. At this point, the cells are placed on aging shelves and stored for an extended period, sometimes days, sometimes weeks, depending on the set temperature and testing protocols. The purpose of this step is to allow the solid electrolyte interface, SEI, to fully stabilize and to observe the long-term behavior of the cells under controlled conditions. During this period, weak or defective cells can be identified and automatically graded out. However, during the initial charging and discharging cycles, gases inevitably form inside the cell. To prevent swelling or deformation, the degassing process is applied. This involves carefully piercing the cell with a hollow lance to evacuate the gas while ensuring that no electrolyte is lost. Once the gas is removed, the cells are resealed. This step ensures that the pouch or casing is fully secured, allowing the battery to maintain structural integrity and long-term performance. In short, aging verifies stability, degassing ensures safety and cell integrity, and resealing prepares the cells for their final stage before pack assembly. This slide explains the formation test and SEI stabilization process, which is key to battery performance and safety. Step 1. Initial hibernation. The cell rests to stabilize its internal conditions before charging. Step 2. Low current charging. A gentle 0.02 C charge begins to form the SEI film, although it remains unstable. Step 3. Second hibernation. The cell rests again to redistribute charge and reduce polarization. Step 4. Moderate current charging. A slightly higher charge at 0.1 C up to 3.95 V completes and strengthens the SEI film, improving stability while preventing lithium plating. The diagrams illustrate how the SEI, solid electrolyte interface, layer forms on the anode surface, protecting it from electrolyte breakdown while allowing lithium ions to pass. Recap of cell formation process. Let's quickly recap the full sequence that leads us into cell formation. The process starts with electrode punching, followed by stacking or winding the electrodes with separators. Next, the tabs are trimmed and welded, and for pouch cells, the pouch is formed and punched out. The electrodes are then inserted into the pouch, folded, and sealed on the top and sides. After this, the electrolyte is filled, and the cell goes through wetting and vacuum sealing to ensure proper infiltration. Finally, the cells form into a structure, where charging and discharging create the protective SEI layer. The process concludes with degassing and resealing, and a final side trim for a clean finish. This sequence represents the complete path from electrode preparation to a finished, stabilized battery cell ready for further testing and assembly. This concludes step 3 for cell formation and finishing. Thank you.